Um, Hi, this is Bo. Tonight I'm going to show you how to do an optimization problem and a rectilinear problem. So we can start with the optimization problem. The question is, a cylindrical can is to hold 20 pi meters cubed. The material for the top and bottom costs $10 per meter squared, and material for the side costs $8 per meter squared. Find the radius and height of the most economical can. So, I already kind of started this one. So first we're gonna draw a picture of what the can looks like, just to get a visual. Then we're gonna write down what we're trying to find: R, which equals the radius, and H, which equals the height. So they give us the volume, which is 20 pi meters cubed. Um, and so we're going to write that down. We're also going to write down the volume formula for a cylinder, which is V equals pi r squared h. And then we should also write down how much it costs for the top and bottom and sides. And top and bottom is 10 per meter squared, and sides are $8 per meter squared. So now we are all right. Sorry. So the first step, we're going to write an equation where it's solving for h. So what we're gonna do is we plug in 20 pi for the volume, and then we write 20 pi equals pi r squared h. Then to get h by itself, we are going to divide this side by pi r squared and this side by pi r squared, so you get h equals 20 pi over pi r squared. Then next we're going to write the surface area of the cylinder. And the surface area for a cylinder is 2 pi rh plus 2 pi r squared. And so we're going to plug in h for that. So it's going to be area equals 2 pi r times 20 pi over pi r squared plus 2 pi r squared. So yeah, we got that. And next we're going to write down the cost, which is what we're looking for. We want to try and find the can that is going to give us the most volume and maximize and minimize the cost. So we're just going to multiply this side of the formula, this side, which is 2 pi r times 20 pi over pi r squared, because that is that's like this area of the sides, and then the 2 pi r squared is the area of the top and bottom. So we multiply this by 8 because that's how much it costs, and we multiply this part by 10 because that's how much the top and bottom costs. So it comes out to look like this. Cost of r equals 8 times 2 pi r 20 pi over pi r squared plus 10 times 2 pi r squared, and then, so we're going to simplify that. So it's going to be C of r equals, hold on. So we got simplified. We just distributed the 8 and the 10. And it looks like 16 pi r times 20 pi over pi r squared plus 20 pi r squared. And we can simplify that even more. We do. Alright, so I wrote it out like this. 16 pi r over 1 times 20 pi over pi r squared. You can cancel this pi r and cancel that pi r. So it looks like it's going to be 16 times 20 pi over pi r squared. But, so you have this, and then you got to, so we multiply these two together, so it's 16 times 20 pi, which is, so it comes out to be like this, simplified, 320 pi over pi r plus 20 pi r squared over 1. And we can simplify this even more by multiplying the 20 pi r squared over 1 by pi r to get a common denominator. So just pi r, pi r, so fully simplified, it's going to look like this: 20 pi squared r squared plus 320 pi over pi r. Now, to find, now what we're going to want to do is we're going to want to take the derivative of the cost equation, because we are trying to find the cane that will cost the least and get the most surface area out of. So we're going to use the quotient rule for derivatives. So it's going to look like, pi r times 60 pi squared r squared minus 20 pi squared r cubed plus 320 pi times pi over pi squared r squared. Alright, so yeah, once you take the derivative, that's what it's going to look like, and we have some simplifying to do. Basically, we're going to distribute the pi r into the first part of the equation, and then just the pi in the second part. So next step, it's going to look like 60 pi cubed r cubed minus 20 pi cubed r cubed plus, sorry, not plus, minus 320 pi squared all over pi squared r squared. Alright, so we got that. Now we can do some more simplifying, but it's just we are subtracting 60 pi cubed r cubed, or doing 60 pi cubed r cubed minus 20 pi cubed r cubed, so that's going to come out to 40 pi cubed r cubed minus 320 pi squared all over pi squared r squared. Okay, so that's what I got when the derivative is fully simplified. So now what we're going to want to do is to find r, we're going to set the numerator equal to 0. So 0 equals 40 pi cubed r cubed minus 320 pi squared. You can factor 40 pi squared out of that equation. So 0 equals 40 pi squared. And you get pi r cubed minus 8. So that's what you get after 40 pi squared is factored, and so now you're just looking at that to be 0. With a little help from your calculator, you can find that r equals 1.3656. Alright. So we found r. There's r. Now we just need to find h. And that's pretty easy. All we do is we plug r into our volume equation that we found way earlier. So that's going to be 20 pi over pi r squared equals h. But you can do 20 pi over pi 1.3656 squared equals h. And then that's basically, you can cancel out the pi's, Cancel. So it's basically just 20 over 1.3656 squared equals h, which equals about 10.73. So there you have it. You got your h at 10.73 and your r at 1.3656. And that will give you the most economic cylinder. So there's all the steps if you want to see all that work again. Alright, so now we're going to do a rectilinear problem. So flip page. And so the rectilinear problem, it gives us an equation. I'm going to write it down. So it gives us that equation. So the first step is finding the equation. So S of t gives us position of the object at t. So the first step for the rectilinear motion is finding the velocity equation. And that's pretty simple. It's just to find velocity, you just take the derivative of this and you get velocity. So velocity is f1 of t equals v of t. Equals 3t squared minus 12t plus 9. So there you go. You got the derivative. S of t is the same as v of t, which is velocity, and it is 3t squared minus 12t plus 9. Alright, now the next part is finding the initial velocity, which you just is when t equals 0, and when t equals 0 in the velocity equation, it's just velocity, initial velocity is 9. That's because this becomes 0, this becomes 0, and ends up being 0 minus 0 plus 9, which is 9. Alright, now we want to find out when the object is stopped. And to find that out is when the velocity equals 0. So we're going to set this equation to equal to 0. 0 equals 3t squared minus 12t plus 9. And so we got that. And now you can factor a 3 out of this equation. So 0 equals 3 times t squared minus 4t plus 3. So that's what it looks like when it's factored. Now we can use the oh no, now we can FOIL this. Sorry, I had a brain fart. We can FOIL this to be 3 times t minus 1 times t plus 3. Sorry, not plus 3, minus 3. So we can FOIL it out to this. That's a factored form. And then that gives us t equals 1 and t equals 3. And so at t equals 1 and at t equals 3, the object is stopped. Alright, so the next part is find the acceleration. And the acceleration equation is easy again. It's the double derivative of s of t, and so it's the single derivative of v of t. So s t equals v1 of t equals acceleration of t. Alright, sorry about that. Which equals 6 t squared minus 12. So you can see it's the double derivative of s of t, the single derivative of v of t, and the equation is 6t squared minus 12. So we're going to want to find the initial acceleration, which is what we did with the velocity, and it's just when t equals 0. So a of 0 equals -12. Okay, so the initial acceleration is -12 because plugging 0 to t, it is 0 minus 12, which is -12. Next we're going to want to, when we're finding speed, like speeding up and slowing down, we need to figure out when t is equal to 0 in the acceleration. I mean, what t is when the acceleration is 0. So to do this, we're going to put the acceleration equation right here equal to 0. So 0 equals 6t squared minus 12. And this is going to be pretty easy. We just add 12 to both sides, so it's 12 equals 6t squared divided by 6 divided by 6. 2 equals t squared. T equals square root plus or minus the square root of 2. So came up with that. You see how I did that? I did just add 12 to both sides, divide by 6 to both sides, then plus or minus the square root of both sides. So t equals plus or minus square root of 2. Next, we're going to do a number line showing velocity and the acceleration. So on that, so we got the number line. On that number line, we're going to mark when both v of t is equal to 0 and a of t is equal to 0. So on the v of t one, it's 1 and 3. On the a of t one, it's negative 1.4 and 1.4 because the square root of 2 is approximately 1.4. So now we are going to see when these equations are positive and negative by plugging in numbers to each equation. So we're going to pick, for this side, we're going to pick a number smaller than 1, so we can pick -1. And with your calculator, you can see that the answer comes out to be positive. So all back here behind -1, it's going to be positive. Then we can pick a number in between 1 and 3 to see what that is. So we can pick 2, and if you plug 2 into the v of t equation, it'll come out to be a negative number. So we can do negative. And then we can do above 3, so we can just pick 4, and if you plug 4 into the v of t equation, it'll come out to be a positive number. So this also means that between negative infinity and 1, the with velocity, the object is moving right, and between when t equals 1 and t equals 3, the object moves left, and then when t equals 3 and t equals infinity, the object moves right again. Alright, so now we can do the same thing what we just did down here. So if you pick a number smaller than -1.4, so we can pick -2, and you plug it into the a of t equation, it'll come out to be a positive number. And if you pick, say, 1, which is in between -1.4 and 1.4, it'll come out to be a negative number. So the graph will be negative in between there. And then pick a number like, say, 2 that's higher than 1.4 and plug 2 into the a of t equation. It will be positive. So we can write plus signs there. Alright, so now you're going to want to draw lines going like that. And this is when we were finding out the speed. So, to find the speed, to know when the graph is speeding up, alright, so I just wrote down some quick notes. And so when you know the graph is speeding up when a of t and v of t have the same sign. So if they're both positive or if they're both negative, then the graph will be speeding up at that time. And when a of t and v of t have different signs, then that's when the graph is slowing down. So that's why I drew these, and you can see that, that's why I drew these lines. So you can see that, well, we don't have to worry about, we just want to figure out when it is between t equals 0 and t equals 5. So we don't have to worry about before -1.4. But if you see, if this was 0, if you see between 0 and 1, they have different signs. So the uh, the graph would be, so the object would be slowing down. Then between t equals 1 and t equals 1.4, they have the same sign, so the object would be speeding up. Between 1.4 and t equals 3, they have different signs, so the object would be slowing down. And between t equals 3 and infinity, they have the same sign, so the object would be speeding up. So I'm just going to write that down real quick. Slow down. 0, 1, and 1.43. Speed up. 1.43. Infinity. Alright, so you can see I wrote it down, just the intervals of when when the object will be slowing down and speeding up, which are what I just told you. Alright, so now we're gonna want to make a graph, make a little picture, and find the total distance traveled. So before I like to do this, I like to write a little key, and you'll see how that's relevant in a second. So a straight line is moving right, and the dotted line is moving left. Alright, so you see that key? Alright, so now we're gonna want to draw another number line. This one is gonna be a little bit bigger. Alright, so we want to find, so we're looking for where the object is going between t equals 0 and t equals 5. So we're going to start off by plugging 0 into the original equation, because that's going to show us position. So we plug in 0 for t, and that's going to come out to 1. So we're going to write 1. So there you go. So this is where the object is. It's at 1 when t equals 0. We got a little dot there for you. So now what we learned from this, after 1, alright, so after t equals 0, what we learned from this, after it equals 0, it's going to go right, because it's positive right here, right? So we're going to go this way, and we're going to figure out where, we're going to plug in where the graph stops, because it'll stop and go the opposite way. So we're going to plug in t equals 1 on the original graph, because as we figured out, that's where the graph stops. So if you plug that into the equation, it's going to come out to be 5. So the position of it will be 5. Right there. So it goes 1 to 5. T equals 1. And then the next time it stops is at t equals 3. And now, as we learned from here, it's going to go left, because this is negative. After 1, it's negative. So, it stops next at 3, so we're going to plug 3 into the original equation, s of t, and that is actually going to come out to be 1 as well. So I drew a dotted line right there, and we know from the key the dotted line means moving left, so it went from 1 to 5, and it stopped at 5, and then it went left and stopped back at 1 at t equals 3. And now, so after t equals 3, it's going to be positive until infinity, so it's going to be always always moving right, and we just need to know where it is at until t equals 5, so we just plug in 5 for t in the original equation, and it comes out to be 21. So here we have our graph right there. So it goes from 1 to 5, stops at 5 at t equals 1, moves back left to 1, stops at 1 at t equals 3, then goes right and is at 21 when t equals 5. So to find the total, we just add up the differences. So we're going to add 1. So he moved 4 spaces from 1 to 5. It moved back 4 again. So that's 8. And then from 1 to 21, he moved 20 spaces. So that would be 28. And you just add them all up. So total is 28. So 28, that's the total he moved. Alright, thank you for sticking through this with me. Here's my final grade assignment in the winter of calculus. Thank you.